This is section 1.3, and we're going to start out with a couple of definitions. The first one is the word relation. And a relation simply can mean a group of numbers. There's nothing special about that group. It could be anything. And we go immediately to the word function, which is really important for the entire course. Function is a special relation, so it's a special group where each x is paired with exactly one y. That's the important word, exactly. It can only be tied to one y. We're going to look at functions in several different ways to just get an idea of what that would look like. So if we looked at what we call maps, they could be any kind of picture, but you've just got a visual diagram. So here we've got our x's, and here we've got y's. And if you note, each x is paired with exactly one y. This would be a function. In this one, we've got 3 and 4, and then we've got 6, 7, 8. But 3 is paired with both 6 and 7. This keeps it from being a function. So your key here is to look at your x's and see if any of the numbers have two lines coming out. If that's the case, it is not a function. Now let's look at it numerically. You're used to seeing ordered pairs, and that's what we've got here. And if you look at this, remembering that these are your x's and these are your y's. X's are the first ones. Is this a function? Every x seems to have a different y, so yes, this would be a function. But in this one, we note that these two right here both have 3 as x. So this is x equals 3, this is x equals 3, and 3 has a partner of 4 and a partner of 9. So that fails the definition. This is not a function. Okay, so we've looked at it with maps and numerically. Let's look at it graphically. The red are our functions or not functions, whatever. They're a sketch of a graph. So we've got this one, and this one. For graphically, we want to draw a vertical line. And the blue line here, I've drawn a vertical line through the graph. If it hits it exactly one time, it is a function. So here, here, but what happens here? It hits it here and here. This one is not a function. The other two are. Now, this should make sense because when you have a vertical line, the equation of that line is x equals 4, because no matter where you go on this line, x is 4, for example. Well, if right here x is 4, and it could be paired with, say, y is 5. So there's that description. Down here, x is still 4, but y might be -3. And we're back to that ordered pair thing, where x is repeated with different y's. So that's why we use the vertical line test, because it would give us the same x's to see if there's two y's. All right, the last way we're going to look at it is equations. And really, we want to get it in a form of y equals something. This is a function. That's a straight line. Okay, all straight lines are functions unless they happen to be vertical. All right, x squared plus 2, that's a parabola. And we saw that right up here, that was also a function. This guy is a circle, and it is not a function. Okay? The key to look at for our equations for right now is if y has a power other than 1. Like right here, that's a 1, that's a 1. Here, we've got y squared, so if we see a 2 there, we're going to know that's not a function. All All right, let's talk about evaluating a function. And if you see f of x, that's essentially the same as y. It's a function of x. So if you are given f of x equals 8x minus 2, and then you are asked to find what's f of 2, I want you to get in your head that that means plug in. That's important. So if it's f of 2, it means plug in 2 for x. So we put 2 in where the x is. 8 times 2 is 16, minus 2 would be 14. So when x is 2, f of x, or y, is 14. Okay? Y depends on x. Whatever x is, that tells you what y is going to be. F of a. Now we don't have a number, but it's the same idea. We're still going to plug in. 8 times a minus 2, and the only thing is you can remove the parentheses and you get 8a minus 2. All right, the last one, same idea. You've got a plus 3. You got to plug it in wherever x was, but now we can distribute. So we have 8a plus 24 minus 2. Then you can combine these two and you get 8a plus 22. All right, the last thing that I want to mention are the two words domain and range. Domain is where x can live or exist. Range is where y can exist. And think of this like zoning restrictions. If you were trying to buy some property where you wanted to build a store, you would have to buy property where that could exist. If it's a neighborhood, you can't build a store there. You know, you would have some laws, some zoning laws. So domain is your zoning laws. These are the places where X can exist, where it's allowed to live. And we'll see how that plays out when we get to the problems. So let's look at the problem set. Okay, I had that where the answers were already there. We wanted to fix that. All right, on this particular one, you are going to have to do some graphing. And this little dot here is going to be an interactive dot for you when you go into MATLAB, and you will actually click on that and move it to help you graph. So let's remember that this will be an interactive graphing process. All right, start by plotting a few points and then sketch the graph. And they give you f of x equals negative 5. That's the same as y equals negative 5. In your problem, this will not be there. That is just there because it's printed. So it's already done, but that won't be there. It'll have to come up after you do your parts. All right, plot a point in the fourth quadrant. We need to remember that the quadrants are these squares that are formed by this cross. This is quadrant 1. They go counterclockwise. So if you need to remember that, you might want to write that down. All right, so in the fourth quadrant, we need a point down here that is a solution. Well, we should know that y is negative 5. So that's where that is. So anywhere along there, we will be picking a point. So you would click on here, move that down and over to some place. Doesn't have to be there. It could be anywhere on this part of the line that you will know is at negative 5. Then it says plot one in the third quadrant. Well, that's here. So you would click this dot, move it down to negative 5, and then over somewhere. I'm going to go there. You could go somewhere different as long as you're on that area. Plot a third point to make sure on the y-axis. So that means we'll click here, we'll come down. We only have one option right there. When you do all three, the line's going to show up and you will have plotted your line. All right, same way, this one's going to be interactive, and this would not be showing. This is just already here. This is giving you some x values that I've highlighted in yellow, and it says f of negative 5, f of 5, f of negative 3. And remember, f of something is telling you to plug it in. So if I plug negative 5 into this, I get negative 5 plus 4 is equal to negative 1. So there's my y value. I have an x, I have a y. So my point that I'm going to plot is negative 5 comma negative 1. All right, let's do the same thing here. Plug 5 in. We have 5 plus 4 is 9. That's my y value. So my point will be 5 comma 9. Negative 3, we're going to plug that in. Negative 3 plus 4. Okay, that's a positive 1. That's my y value. There's my x value. So negative 3, 1. Now I'm going to plot these 3 points. So what they gave you was the x values. You had to figure out the y values. And these points are already on here. They would not be in your problem. You will have to plot them. So negative 5, negative 1 is right there. You would click here, you'd move over, and you'd get that, and you'd let go of it. This one is over 5 up 9, so there's my 5, 9. And this is at negative 3, positive 1. And once you've plotted all 3, the line will draw itself. Okay? All right, let's move to number 3, I didn't bring the actual problem from the problem set in, but I believe that this is it. So let's kind of go over. This is just more of that plugging in. You are given that h of x is x plus 11, and you're given x is 0, negative 23, negative 3, 1. You literally are plugging in these 4 numbers. So h of 0, you put in 0 plus 11, you get 11. Negative 20 plus 11, you get negative 9. Negative 3 plus 11, you get 8. And 1 plus 11 equals 12. Now, it asks about the domain, and I believe it's a multiple choice. Is there anything we could plug in for x that would be a problem? No, x could be any number in the world, so that is all reals. All right, let's look at number 4. Number 4 is very much the same. Gives you a function, g of x, and remember this letter could be anything. Doesn't have to be f, could be g, h, whatever. And then it gives you 2 things, x equals 4 and a minus 2. Both times we're going to plug in whatever we're asked to find for wherever the x is. So here I'm going to go 3 over 5 minus 7 times 4. And then I'm going to clean that up. 3 over 5 minus 28. That's a negative 23. And usually in math lab they don't like the negatives on the bottom, so put it out in the middle of the fraction. Okay? All right, same thing with a minus 2. Let's plug that in. 3 over 5 minus 7 times a minus 2. We've got to distribute. This negative 7 is going to go both places. All right, so we've got 3 over 5 minus 7a, negative 7 times negative 2, plus 14. Then I've got 3 over 5 and 14 is 19 minus 7a. Okay, so that would be that one. Then it asks about the domain of this guy. There is a problem with this one. This one is in a straight line. We've got a denominator here. And the denominator of a fraction, we are never allowed to divide by 0. So to figure out what the exact restriction is, we're going to take the denominator and set it equal to 0. So that's what I've done. I've taken 5 minus 7x and set it equal to 0. Now let's solve that little equation. We would subtract 5 from both sides. That would leave negative 7x equals negative 5. And then what would I do? I would divide the negative 7 on both sides. Okay? That would leave me x equals, and that negative stuff's going to go away because negative divided by negative, and I'm going to have 5/7. So x is 5/7 is the one number in the world that if I plugged in there, it would make it be 0. So that is my restriction. That's where x cannot live. That's that zoning restriction. So the domain, that means where x can live. It's everything where x is not equal to 5/7. That's the domain. You do this process, find out what the restriction is. The domain is everything except that restriction. Okay? All right, let's go look at number 5. All right, number 5. Find f of 1 and f of 2. Well, now we don't have an equation. We can't plug in. But we do have some x values. So this is saying when x equals 1, what is y? Go to x is 1 right there. Well, we're right on the x-axis. So what's the y value there? That's 0. Okay? When x is 2, you go to 2 on the x and you move till you hit the graph. We're right there. Okay? If you count up, you would find that y is 6. Right there, y is 6. All right, when x is 3, you move 3 over, move up. Where are we on the y? We're at 4. So that's what would go in those boxes. All right, now this one is, we're going to pull in the domain and range. They've given you a little piece of a graph, and hopefully we remember that sometimes things are included, sometimes they're not. If they are included, it's usually closed in. If they're not, and it's just a boundary, it's an open circle. And that has to do with open circle would mean that you just have less than or greater than. If it's a closed in circle, it means you're going to have an equals under there because it could include that. Okay, so that's what we want to remember. All right, let's just think about something. Domain is where x lives. All right, so what's the leftmost x value here? That'd be 1. Okay, what's the rightmost x value? That'd be 7. All right, so x falls between those two numbers. And this one has a closed circle, so it's going to be less than or equal to that. This one has an open circle. It's going to be greater than or equal to the, sorry, that doesn't have the equal. All right, so now we've written it. Let's look over here and see which of these choices meets that. That would be this one. Okay. All right, let's do the same thing for the range. The range is about y. What's the lowest y that we have? Right there on the y, we are at 3. And what's the highest y? Highest y would be 6. So y is going to fall between 3 and 6 in this graph. And again, we've got the closed circle there. We've got the open circle there. Okay? And so that choice over here would be this guy. All right? Let's go to the last two. All right, again, what is f of -4? Something you have to be careful when you look at MATLAB graphs. They don't always go by ones. If you look here, this is 0 to 20, so these are going by 2's. So everything's by 2's. Here is -4. We go up till we hit the graph. It's between 4 and 6, so that y value would be 5. Okay, you have to be careful when you're working on MATLAB. Let's look at the last one. F of -1. So we're going to go to -1. We move up till we hit the graph. What's the value there? Y is 1. f of 0, go to 0 on the x, up there. What's the y value? 3. F of 1, go to 1 on the x, move up, you're still at 3. So I think that should help you get going, and you should be ready to do your homework for 1.3.